Okay, this video we're going to be talking about logarithmic functions and its inverses. Okay, so when I'm talking about logarithms, they are the inverse of what we have been doing, exponentials. So exponentials, remember, were things like 3 to the x, or 4 to the x, or 5 to the x plus 1. Logarithms are the inverse equation of this. Okay, so this is what our basic logarithms could look like. So we can go from logarithm, or we could do exponential form. So b is always going to be your base. So here are my bases. And then c is going to be your exponents, and a will be your powers. Okay, and again, the logarithm is the inverse of our exponential equation. Okay, so first off, 2 to the 4th, if I wrote it out the long way, is 2 times 2 times 2 times 2. Okay, that equals 16. Okay, so another way of writing it is this. 2 to the x equals 16. Well, what, when I fill it in for x, can get me that 16? Well, 4. 2 to the 4th can get me 16. Another way of writing this, instead of exponential, is if we write it in a log form, like this. Okay, so it's going to mean the same thing, so I'm going to write it out. So we always start with our base and then lead to our exponent. So my 2 is going to be my base in this, and then this is going to be my exponent, or power, and it's going to equal that number there. Okay, so if I start with my base, I got 2 as my base, x is my exponent, and it's going to equal that 16. So the thing that represents x to get me to 16 is going to be 4. Okay, so we can write it either way. This is going to be the logarithm way, and that's going to be my exponential way. Okay, so my next one here, this is my base. Okay, the way that we say this is log base 3 of 81. So this always, that little number always represents the base of whatever my power is going to have underneath it. Okay, so we have base, we have our power or exponent, and it should be equal to that 81. So I got my base, my power, what it's equal to. So this time I'm trying to figure out a value that when I plug it in for x, it gets me 81. So if I do 3 to the 1st, I get 3. If I do 3 squared, I get 9. If I do 3 cubed, I get 27. If I do 3 to the 4th, it gets me 81. So basically, if I was able to type in my calculator, log base 3 of 81, my answer then would be 4. Okay? So evaluating a logarithm, so basically we're changing it into an exponential. So if I was able to type in log base 8 of 32, what would it equal? Well, right now I don't know what it equals, so we're just going to represent it as x. So 8 is my base. X is going to be my power that I'm trying to find, and it's going to equal 32. So I start with my base, I do my power, and what it is equal to. Okay, this time I can't think of anything that when I plug it in for x, it gets me 32. So I need to break down the bases. So if I break down this, I know that I could break it with a 2. Well, what to that 2 can get me to 8? Well, 2 cubed can get me to 8. So I can put that little 3 there, but the x still has to remain here. Okay, if I simplified 2 cubed gets me that 8, that's why it works. Now I got to do the other side. For us to be able to do this, they need to have the same base. Well, what, when I take it with this 2, gets me to 32? Well, 2 to the 5th does. If I have the same base, so it'd be like saying if x equals x. They cancel on both sides because I would subtract x and it would cancel on both sides. So my bases, since they're the same, we can cancel them and just set what our powers are equal to each other. If I solve for x, I get 5/3. If I want to check my answer, I would type in 8 to 5/3 and it should equal 32, which it does. Okay, so my next one, we're going to set it equal to x here. So I have my base to my power, base, power, and what it's equal to. So I have my base, my power, and what it's equal to. So what, when I fill it in for x, gets me 125. If I take 5 to the 3rd, it gets me 125. Okay, my next one, I'm going to set it equal to x. So I have my base to my power. There's my base. Here's my power and what it's equal to. So I have 4 to the x equals 32. Well, nothing when I plug it in for x right now is going to work, so we need to break it down. So what when I have 2 as my base, can I get to 4? Well, 2 squared gets me 4, and then I still have this little x here. Now I need to do 2. 2 to the what gets me 32, that's 5. If I have the same base, they cancel, so I got 2x is equal to 5. Divide by 2. I got 5 over 2 for x. Okay, I could plug it back in here, take 4 to the 5 over 2, and it should equal 32 to check my answer. Okay, now I'm giving you the log and we need to write it in exponential. So something that's like 4 to the x or 3 to the x. So basically my answer can't have logs in it anymore. So we're doing it the same way, my base to my power. So here's my base, here's my power, and it's equal to. Okay, these look like the exact same as what we have been doing, but these ones, we were solving to figure out what it equaled. Now I have what it equals, so I'm not solving for anything. I'm just rewriting it into the form we've been doing. So I have my base, my power, in what it's equal to. The way to double check to make sure you wrote it out right, if I take 4 to the 4th in here, it should equal 256. Normally, that 4 was representative of x and we were trying to find it. Now I'm just rewriting my equation. So my next one, base, power, what it's equal to. So 7 to the 0 equals 1. Anything to the 0 power is 1, so it worked. Okay, my next one, base, power, what it's equal to. So I got 12 to the negative 2 equals 1 over 144. If I type that in my calculator, it will most likely give me the decimal form of what this is. But if you do the double arrow where it gives you the fraction, you should get the same thing. Okay, common logarithm. So if we think back, when I was doing square roots, there was always a little imaginary 2 here. Or if I had x, so 3x, what exponents did they have? We knew that they were like little 1s sitting there. Okay, logarithms have the exact same thing, where they also can represent a base of 10. So if you don't see a base here, it will always represent base 10. This is the form that your calculator is in, graphing calculator or non-graphing calculator. So these ones you can actually type into your calculator because they have base 10. Okay, so if you don't see a base there, it's 10. If I'm rewriting this, technically you could type in log 10, press equal, and it will pop out that 1. If we're doing it our normal way of converting it to exponential, I got my base to my power, so 10 to the 1 equal to 10. Well, 10 to the first power equals 10. Okay, so that's kind of a way to double check. But if you typed it in your calculator, it should equal 1 because your calculator is in base 10. Okay, so talking about their graphs, since it's the inverse of an exponential, here is my exponential in the left side here. Here is the inverse of it. Since it's log base 10, we still have the 10 here. So you can kind of see what our graphs will look like now. So that's going to be our generic graph from when we're graphing it, and then we're going to be moving it. So to move it, remember outside here is up or down. Inside is going to be left or right, and it's always going to be the opposite of what you think again. So left slash right, opposite of what you think. My K, or my A in the front, is either going to compress it or stretch it. And if it's a negative A, remember negative on the outside, you want to keep your X on the outside. It's going to reflect over your X. If this was negative on the inside, it would reflect over Y. So the same thing that we've been doing. Okay, so if my first one here, let's talk about the translation. So this would be down 6. This right here would be left 2. If I had a different base, right now it's a base 10, which means I can type it in my graphing calculator. If there was a different base there, we don't include that in like the stretch or compress or anything. That's just talking about its base. Okay, just like when we were doing 2 to the x, this was not a stretch because it was the base of the formula. It was our generic parent function. If there was something in front of it, then it would have stretched. Okay, so, oops, left 2. Okay, so if I were to type this in my graphing calculator, I would make sure to type in log of x plus 2. I end my parenthesis and then I do my minus 6. This graph is going to be a lot harder because all the decimals are going to be super duper close together. So when I do it, I'm going to start it at -1. So negative 1, 0, 1, 2. So negative 1, we got negative 6, negative 5.6, negative 5.5. 2, I got negative 5.3. Okay, so I go left 1, down 6, 0, negative 5.6, negative 5.5, negative 5.3. So it kind of shoots off like this. Okay, my next one, it is going up 1 because that plus 1, it is going right 3. We can type this in our calculator because it's a base 10. So when I type in log of x minus 3. I end my parentheses and do plus 1. I press graph so I can see where it's going to look. I press second and table. So here's my xy. Let's see, I'm going to start it at 4. So 4, 1, 5, 1.3, 6, 1.4. 7 is 1.6, and then I don't think I have enough room on my graph, so I'm going to go right 4 up 1, right 5, 1.3, and then this is 1.4, so he kind of shoots off like this. Okay, inverse equations of logs, since they're base, we use the base to get the base of our equation for our exponential. So whatever your base is going to be the base of your equation. So I got y equals, the base of my log is 3 to the x, because my exponential has to be to that x power. Okay, my next one I got a base of 2, so I got y equals the base of 2 to the x. Okay, what is the logarithmic form of each equation? So this time I need logs in my equation. Okay, so I'm going to do it similar to what I have been doing. This is going to be my base. This is going to be what's next to my log and what it's equal to. So I'm going to do log of my base of 10, my big number, 100, and what it's equal to. My next one, by base, the other part of my logarithm, and then what it's equal to. So I got log base 3 of 81, which is equal to 4. So it's kind of the opposite direction of what we have been going. So here is my base of 6. The other part, what it's base of, what it's equal to. So I got log base 6 of 36 and what it's equal to. If you want to double check to make sure you did it right, you can go the other direction. So normally we did base power what it's equal to, and if you look, that means 6 squared equals 36. That's what I started with. So if I want to check this one, I do base power what it's equal to. That's what my step 1 was. My last one, base power, so 10 squared, what it's equal to, 100. That's what I started with. So you can kind of double check. It's the opposite direction of what we've been going, and we're putting logs in it this time.